Carol Wilson, Editor-at-Large for Light Reading, and I'm here at the Open Networking Summit with Haoyu Sung from Huawei. And he's got a very interesting demonstration of something called the protocol oblivious forwarding and dynamic network probes. And basically, you're dynamically enabling probes in the network to feed information back in for decision making on an application-specific basis, right? Mm-hmm. Okay, why don't you show us?
Okay. So POF stands for Protocol Oblivious Forwarding, which is an innovation technology for the network data plane.
Okay.
So the basic idea is to open the data plane programmability to the users. So through an open and standard interface. So we built this prototype based on the extension of the OpenFlow protocol.
Okay.
But we make the OpenFlow protocol independent and also make the data plane stateful. So for any applications, we can separate that into two parts. One is the static part, another is the dynamic part. Okay. So the static part, we can use some high-level language like P4 to program the basic forwarding data plane, forwarding pipeline. And at the runtime, we may need to do some minor modifications or incremental updates to the data plane. Then we can use the same interface to do that.
Okay.
So the data plane device is based on a very simple abstraction. You can see it's like OpenFlow pipeline with a table, mesh table, and actions.
Okay.
But the actions use a set of instruction set. We call that POF-based.
Okay.
It's protocol independent, and with that instruction set, we can design any custom actions and dynamically load these actions into the data plane.
Okay.
And then we can install the flow table entries. Each table entry will have a pointer to pick some action to execute.
Okay.
So using this way, we can dynamically load this and change the runtime function in real time.
Okay.
Also, we have the shared resource. So this shared resource can be accessed by these custom actions. And in that case, so we can support stateful data plane processing. We have started this project 3 years ago. And along this line, we have made a lot of progress. You can see we can already support the P4 programming. We already done the WAN-based field trial. And in this year, we actually developed a new application. We think the application can address the service provider's pain point, which is to enhance the data plane visibility.
Okay.
So we call that dynamic probes. So if we look at the SDN model, so we basically collect some data from data plane, then do the analyze, then make some decision to change the forwarding plane again. So the key point is how you can get the data from the data plane. So there are some protocols, but they only point solutions. Also, in most cases, it just gives you the raw data.
Okay.
So you use the raw data and run some big data applications on top of that.
Okay.
That's not very efficient because for the most of the application scenario, the data plane cannot predict what data will be needed.
Okay.
So it's better to be able to install this dynamically.
Okay, because if I understand what you're saying, then basically instead of having this just sort of massive data dump, you zero in more carefully on what's actually needed for that application.
Right.
Okay, that makes a lot of sense.
We do that only on demand and in real time.
Okay.
So for any data analytic applications, we use a P4 maybe just to program the data plane made pipeline.
Okay.
And we use this runtime interface to install the probes dynamically.
Okay.
And with this support, we can greatly enhance the network visibility.
Okay.
Basically, you can see anywhere and at any time. Also, once we provide this dynamic probe mechanism, we can run different customer applications to support quality of experience, security, custom care, and other optimization applications.
Okay, so you're really tailoring that network information to the specific application, and you can do it for whatever application comes along. That's interesting. Okay. That's what you mean by the next generation of SDN.
Yes.
That makes a lot of sense. Okay.
Yes. So here's a more clear diagram we have. We have this interface. Just download. You program your probes.
Okay.
And push down to the data plane. So the simplest probes could be just some simple counter to attach to the flow, to the queue, or to the port.
Okay.
But the more complex probe could be some state machine. You use an instruction to program state machine, use that to trigger some event. So only when that event is triggered, it reports to the control plane applications. So in the future, we will build a big data analytic platform based on this. So every application will be compiled to a set of network probes and then disseminated to the data plane.
Okay.
And from then on, they start to collect data and analyze that and present to the application.
But again, that's all being done on an application-specific basis. So you're not just fire hosing everything up. And you can change this on the right side. You can change the configuration as you need to.
Right. Okay. Potentially, there could be also many applications.
Right.
They will require data simultaneously.
Okay.
Then you will have a layer in the controller to orchestrate all these different requirements.
Okay. Yeah. That makes sense.
But the underlying mechanism is very, very simple.
Interesting. Okay. All right, great.
Yeah.
All right, well, thank you so much for the demonstrations. It's fascinating stuff as we see the number of applications grow, how SDN is going to grow and change as well.
Yeah, thank you.